Often on the GRE, we need a quick way to compare the size of two fractions. Sometimes a quantitative comparison will ask us to compare them directly, and other times comparing them will be part of a larger problem. So there are a few important rules to know here. First of all, a very basic rule, changing numerator, same denominator. If we keep the same denominator, then making the numerator bigger makes the fraction bigger. Making the numerator smaller makes the fraction smaller. This is probably pretty obvious. And so these are some examples. These are probably things that most people find pretty easy to see which one is going to be bigger. Now, let's talk about the case of changing denominators, same numerator. This is the one that can confuse people sometimes. It's a little bit anti-intuitive. If the numerators are the same, then making the denominator bigger makes the fraction smaller, and making the denominator smaller makes the fraction bigger. If we think about fractions as division, if we have a certain number of cookies, well, if we divide it by more children, then each child is going to get fewer cookies. But if we divide it by fewer children, each child is going to get more cookies. And that's basically what's going on here. That's why making the denominator smaller makes the quotient, makes the fraction bigger. So bigger denominators make for smaller fractions. So for example, we know that 2/5 has to be bigger than 2/7. We know that 3/11 has to be smaller than 3/10, and we know that 7/24 has to be bigger than 7/36. These are examples of things you need to be able to see very quickly and be able to compare these fractions very efficiently. What if we change both the numerator and the denominator? Well, if both the numerator gets bigger and the denominator gets smaller, then the fraction definitely gets bigger. For example, if we change from 3/8 to 4/7, well, we've made the denominator bigger, and we've made the numerator bigger, and we've made the denominator smaller. And so those two rules combine, so definitely 4/7 has to be bigger than 3/8. That's very clear. What if we increase both the numerator and the denominator? Does that make a fraction bigger or smaller? Well, it depends. First of all, it depends on how we increase. First of all, remember that if we multiply both numerator and denominator by the same number, we get an equivalent fraction. So for example, we start with 3/7, multiply both numerator and denominator by 12, we get 36/84. Those are two completely identical fractions, the same mathematical value. We can put an equal sign between them. We do not change the value at all in that case. What if we add the same number to both the numerator and the denominator? So this is an interesting little trick, and this might save you time if you can understand how to apply this. If we add the same number to both the numerator and the denominator, then the resultant fraction is closer to 1 than was the original fraction. So for example, suppose we have a number line here. Well, if the original fraction is somewhere down here, adding the same thing to the numerator and denominator moves it closer to 1. So that moves it up. But if the original fraction is somewhere here, adding the same thing to numerator and denominator moves the fraction down. And in both cases, you could say 1 is a kind of central attractor pulling the fractions closer. So let's talk about this with numbers. Suppose we start with the fraction 2/5. Of course, 2/5 is less than 1. Now add 6 to both the numerator and the denominator. We get 8/11. Well, how we made things bigger or smaller? Well, think about where we are on the number line. 2/5 is less than 1. Adding the same number to the numerator and denominator moves the fraction closer to 1, which in this case moves it up, and so we see that 8/11 has to be bigger than 2/5. Again, start with 7/4. 7/4 is larger than 1, of course. It's an improper fraction. Add 1 to both the numerator and the denominator, we get 8/5, and we might ask, have we made things bigger or smaller? Well, again, think about where we are on the number line. On the number line, 7/4 is bigger than 1. Adding 1 to the numerator and denominator moves it closer to 1, which means it moves it to a number that is smaller. And so we see that 8/5 has to be less than 7/4. What if we add something different to the numerator and the denominator? How does the value of the fraction change? Well, suppose, for instance, we add 2 to the numerator and 5 to the denominator. The resultant fraction will be closer to 2/5 on the number line than was the original fraction. So that means if we're starting out here less than 2/5, adding 2 to the numerator and 5 to the denominator will move it closer to 2/5, moves it up, makes it bigger. But if we're starting over here on the number line, adding 2 to the numerator and 5 to the denominator moves it closer to 2/5, moves it down. So now the central attractor is not 1. The central attractor is 2/5. So for example, suppose we start with 1/8, 1/8. Clearly this is smaller than 2/5. It has a smaller numerator and a bigger denominator. So this is smaller than 2/5. We're going to add 2 to the numerator, 5 to the denominator, get 3/13, and the question is, have we made things bigger or smaller? Well, think about where we are in the number line. Here's 1/8, less than 2/5. Adding 2 to the numerator, 5 to the denominator moves it closer to 2/5, which means it moves it up, and therefore we see 3/13 has to be bigger than 1/8. Another example. Start with 3/4. 3/4 is definitely larger than 2/5 because we've made the numerator bigger and the denominator smaller. So this is larger than 2/5. We're going to add 2 to the numerator, 5 to the denominator, get 5/9. Have we gotten bigger or smaller? Well, think about where we are on the number line. 3/4 is up here, larger than 2/5. Adding 2 to the numerator and 5 to the denominator moves us down, moves us to 5/9. So we see that 5/9 has to be less than 3/4. So it allows us very efficiently to compare these two fractions. Now I'll state this general rule. This general rule involves a lot of algebra, so this might be a bit confusing, but I'll go through this for the people who like the algebra. If we start with a fraction a/b, and then add p to the numerator and q to the denominator, the resultant fraction, which will be a plus p over b plus q, that resultant fraction will be closer to p over q than was the original fraction. So if the original fraction is smaller than p over q, then doing this makes it bigger. If the original fraction is larger than p over q, then doing this makes it smaller. And so again, whatever we're adding p to the numerator and q to the denominator, that fraction p over q becomes the central attractor. Fractions here move closer to it, fractions here move closer to it, so the ones here get larger and the ones here get smaller. If you see to apply this rule, it can be a very powerful shortcut. If we subtract numbers from both the numerator and denominator, the effect is the opposite. So I would recommend think in terms of adding. Think in the direction that you'll be adding, and that will make it easiest to apply the rule. If we add to the numerator and subtract from the denominator, or vice versa, then whichever fraction has a larger numerator and a smaller denominator is bigger. Now here's another completely different trick for comparing two fractions. This is also a really time-saving shortcut. Suppose in a problem we have to compare quickly the size of 7/11 and 5/8, two relatively close fractions, to decide which one is bigger. Using the calculator, then writing the decimals down to compare them would be time-consuming. Instead, write the fractions with a double question mark sign between them. This double question mark could represent greater than or less than. So we don't know. 7/11, is it going to be larger than or smaller than 5/8? We don't know, so we're just writing double question marks. Now simply cross multiply. So we get 7/8 on one side, 5 times 11 on the other side. 7 times 8 is 56. 5 times 11 is 55. Of course, 56 is larger. So, of course, the inequality has to point in the same direction before we cross multiply. Cross multiplying for positive numbers, cross multiplying is not going to change the direction of the inequality. And therefore, this means that 7/11 has to be bigger than 5/8. So again, this can be an enormously simplifying shortcut to compare two fractions. Here's a practice question. Pause the video here, and then we'll talk about this. Okay, a few things to notice. We notice that essentially what we've done is we've added 100 to the numerator and 200 to the denominator. And of course, 100 over 200 equals 1/2. Well, 4/5 is larger than 1/2. So when we start with 4/5 and add 1 in the numerator and 2 in the denominator, or anything else in that ratio, the fraction gets smaller. And so we can see, just by applying this trick, that column A must be bigger. And again, since 4/5 is up here, adding 1 to the numerator and 2 to the denominator, or anything in that ratio, is going to move it closer to 1/2, which makes it smaller. And so the fraction in B is smaller, and the fraction in A is larger. Here's another practice question. Pause the video, and then we'll talk about this. At a certain school in December 2013, there were 6 teachers and 200 students. On January 2nd, the day after New Year, 1 teacher and 35 students joined the school, and no one left the school. And so we want to compare the teacher-student ratio in December and the teacher-student ratio in late January. Well, this is tricky. The teacher-student ratio in December is 6 over 200, and I'm just going to simplify this right away to 3 over 100. So that was the old ratio. And then we're going to add 1 and 35. Well, here's the thing. We know that, suppose we make a number line. Here's 0, and here is 1 over 35. Well, if 1 over 35 is bigger than this fraction, then adding 1 to the numerator and 35 to the denominator will make the fraction bigger. But if 1 over 35 is smaller than 3 over 100, then adding 1 to the numerator and 35 to the denominator will make it smaller. So it really comes down to a question of which one is bigger. Is it 3 over 100 or 1 over 35? Well, I'm going to cross multiply. 3 times 35 is 105. And of course, 1 times 100 is 100. That means this is bigger. That means 3 over 100 is bigger than 1 over 35. Adding 1 to the numerator and 35 to the denominator makes the fraction smaller. So this new ratio is going to be smaller. And so that means that column A is bigger. In summary, with the same denominator, bigger numerator means a bigger fraction. That's a really basic rule. You have to have that at your fingertips. With the same numerator, bigger denominator means a smaller fraction. This is a little bit trickier to see, but you have to have this one absolutely at your fingertips. These first two you have to know inside out. We talked about the rules for adding numbers to the numerator and the denominator.